Okay, in this video we're going to be working on the test review for test 4. So you can see number 6 says perform the indicated operation, and then it has x over x squared minus 49 minus 1 over x squared minus 14x plus 49. So this operation that it's talking about, what we need to be doing is the subtraction in between. So we're saying the first fraction minus the second fraction. That's the operation that we're talking about. Please don't try to change this into multiplication or anything else. It's a mistake we see often. So we have x over x squared minus 49 minus 1 over x squared minus 14x plus 49. And hopefully you remember that in order to add or subtract two fractions, you need an LCD, a least common denominator. So what we need to do is actually factor both of these denominators to see if they have any common factors. X squared minus 49 hopefully looks familiar to you. It is a difference of squares. So x plus 7 times x minus 7. And then 1 over x squared minus 14x plus 49. So this is a normal trinomial. We'll have two sets of parentheses. We know we have an x in each one. And then we want to start looking at our c term, the 49, and find factors of 49. Right? And so 49 is not prime, but it doesn't have a lot of factors. It has 1 and 49 and 7 and 7. So 7 times 7 would give us 49, and 7 plus 7 would give me 14. But since this is a negative and this one is a positive, it means that I need both to be a negative 7. And if you fold this back out, you would see you get x squared minus 7x for your middle terms, right? And then your plus 49. And minus 7 would give me a negative 14x. So that works. And you should always be checking. It takes very little time, and it will prevent you from getting an incorrect answer. So now, looking at these two denominators, right, we want to see what they have in common. They both have an x minus 7. One has an x plus 7, and one has an x minus 7 for the other factor. So the LCD is actually only write one of the x minus 7s once, right? That counts for the one that's in each one, and then you write what's left. So we add the x plus 7, and we add the other x minus 7. And it would just be these three multiplied by each other. I would not multiply it out. It's a lot of work. It's very cumbersome. You're going to get a cube, and next to the cube, I just would write it like this. So what we need to do, though, is see, looking at the first one, has x plus 7, x minus 7, what is it missing? An x minus 7. So I'm going to take the first fraction times an x minus 7 over x minus 7. Because remember that anything over itself is equal to 1. The next one, the other fraction, has the x minus 7 times x minus 7, right? So we're looking for the x plus 7 on this one. So we're going to multiply by an x plus 7 over x plus 7, which gives us on the top here, multiply straight across, so I get x times x minus 7 over x minus 7 times x plus 7 times x minus 7. Right, just write it all out. Don't multiply it or anything, just leave it like that. Minus an x plus 7 on the top, 1 times x plus 7, x minus 7 times x minus 7 times x plus 7, right? So now they have the same denominator and we can combine. One thing we need to remember is that this is saying minus this whole second fraction. So this negative sign actually gets distributed into both parts of the numerator. If you don't do this, you're going to wind up with the wrong answer. So please make sure you're paying attention. Anytime it's minus a fraction, it gets distributed through the whole second numerator. And I am going to go ahead and multiply on the left one also. So I get x squared minus 7x minus x minus 7 all over x minus 7, x plus 7, x minus 7, right? Combine like terms, I get x squared minus 8x minus 7 all over x minus 7, x plus 7, x minus 7, okay? So now we need to look at the x squared minus 8x minus 7 all over x minus 7, x plus 7, and x minus 7, right? And we should look at the numerator to see if it's factorable. We're looking at factors of 7. It's prime, so you only have 1 and 7. Is there a way that we can combine these to get a negative 8? Right? If they were both negative, then you would be able to. However, if they were both negative, when you multiplied them, you would get a plus 7. So this actually is not factorable. Your answer, you would just stop here, and this would be your answer. Okay, here again, perform the indicated operation. This time we have z plus 3 over z plus 6 minus 4. And you see with my z's, I put a little dash through. You need to find some way to denote some of these letters, right? If it's a T or a Z, something that could look like another number or operation, you could get into trouble. If you mistake this Z for a 2 and you add them at some point in your work, then obviously your answer is going to be wrong. So you need to find a way to note to yourself that it's Z and not 2. I do the little line. That's how I remember. So again, we're talking about subtraction. We have a fraction and a whole number. We need to find an LCD. Anytime that we're going to add fractions or subtract fractions, we need an LCD. So since 4 is a whole number and it doesn't have a denominator, we just want to use the denominator of the other fraction. So our LCD is actually z plus 6. And I'm going to take the 4 and multiply by z plus 6 over z plus 6. And this is technically 4 over 1. So my first fraction does not change, and my second fraction becomes 4 times z plus 6 all over z plus 6, okay? Now, here again, we have this minus the second fraction, so hopefully you remember that this is getting distributed. What I don't want to do is distribute it to all 3, right? Because it's being distributed if I just move it to the 4. So what I'm actually going to do is write z plus 3 over z plus 6 plus a negative 4 times z plus 6 all over z plus 6. And all I did was change it to a plus, and I moved the negative. I distributed the negative to the 4. Now, when I distribute the 4 through, I'm going to be multiplying the negative through also. So z plus 3 over z plus 6 plus a negative 4z minus 24 all over z plus 6. Now I want to bring the top together. I have z plus 3 minus 4z minus 24 all over z plus 6. So you can see how this 2 looks oddly familiar to the z, especially when you're hurrying or writing quickly or something like that. So again, please make sure you're denoting which one is your z. So now we want to combine like terms. We have a z minus 4z that are the same, right? So 1 minus 4 gives me a negative 3z. A plus 3 minus 24 gives me a negative 21 all over z plus 6. Right? So you can go ahead and factor in the numerator, right? There's a negative 3 that could come out, and then it's z plus 7 over z plus 6. Nothing can cancel. It should take either answer in my math lab. It should not mark either of these two answers incorrect. They're both equivalent answers. Okay, so the next one is z equals 7u over t plus s, and solve for s. Okay, so we have z equals 7u over t plus s. And I think it is important to denote here that everything is capitalized. So please make sure when you go to plug it into the computer, whatever your answer is, that it's capitalized. I always make the connection to English. If I use a capital W versus a lowercase w, I'm not saying the same thing if I'm writing a paper, right? If I don't capitalize any of the first letters in my paper, then my teacher's going to mark me off. It's the same thing here. We're saying that capital T is not the same number as lowercase t, or capital Z is not the same number as lowercase z. So my math lab will mark you incorrect if you change any of these to a lowercase if they started out as an uppercase, or vice versa. Okay, so it says solve for s, and so you can see it's t plus s down here in the denominator. That's where our s is. We cannot just split this s because it's addition in between. So what we have to do is multiply both sides by the denominator, right? We learned this back in module 2, I think was when we first started using this idea to eliminate fractions. We want to eliminate this denominator, and it leaves us with t plus s times z equals 7u. I still need to get this s moved, and I can't just move it right now because I'm multiplying by the z. So I actually need to go ahead and distribute the z. So I get zt plus zs equals 7u. Now I want to get the s by itself. So I'm first going to minus zt, okay? And I have zs equals 7u minus zt all divided by z. So s equals 7u minus zt over z. You follow the same operations as if there were numbers. You just can't actually combine anything. You just follow the steps. Okay? So the next one says 4 over m plus 4 over 7 equals 4 over 7m. And we should solve for m, is what we are doing with this one. So here again, we're going to be looking at the LCD, because we know to add fractions we need the LCD, but because we have an equation, we can actually eliminate the fractions like we did in the previous problem and make our life a lot easier. So to do this, what we want to do is look at all the fractions in our equation and say, what is the LCD of all of these fractions? So one has a denominator of m, one has a denominator of 7, and one has a denominator of 7m. Hopefully you see that 7m is just the other two denominators multiplied by each other, which means that our LCD is just 7m, right? But instead of getting an LCD, what I want to do is I want to multiply each fraction by the LCD, okay? So I'm going to multiply this one. So I'm going to multiply this one by 7m, and this one by 7m, and this one by 7m, okay? And what you can do, you can multiply it. Hopefully after you get more comfortable with this concept, it will be a little easier. What I'm going to do is write 7m times 4 over m, right? See, I just put it over 1 and you multiply straight across, but I didn't actually multiply it out. I just wrote it next to each other. Plus 4 times 7m over 7, same thing, equals 4 times 7m over 7m. Now I want to look at, remember, anything over itself is equal to 1. So I have an m over m that's going to cancel out, and I'm just left with 7 times 4, which is 28, plus here I have a 7 over 7 that's going to cancel out, so I'm left with 4 times m, equals to 7m over 7m cancels, so 4, right? And now it's just a basic equation to solve. Subtract 28 from both sides, right? So I get 4m equals a negative 24, divide by 4, m equals a negative 6. One thing to note with these, because it started with a fraction, I need to check my answer. I need to say, if m is equal to negative 6, is that okay? So if I plug it back in, remember when we talked about domain, we said that we do not want the denominator to be 0. If the denominator of a fraction is 0, it's undefined, right? We say that it's no and it's undefined if there's a 0 on the denominator. So if my answer, m equals negative 6, caused a 0 in the denominator, it would not be a part of the domain, and we would say that there was no solution. If you look at this one, if I plug in negative 6, I just get negative 6. If I plug in negative 6, I get negative 42. Neither of those is 0, so this is okay. So my answer is m is equal to negative 6.